Hey, welcome to The Explainer. Today, we are going to break down a fundamental rule of the universe that, believe it or not, actually makes chemistry a lot simpler than it seems. It's a law that's at work everywhere, from a roaring fire to the fizz in your soda. Okay, let's get right into it.
So I want you to picture a campfire. You start with this big pile of wood, right? And a few hours later, all you have left is a little pile of ash. So where did all that wood go? Did it just poof, vanish into thin air? Well, the answer is a huge nope. And it's the key to one of the most important rules in all of science.
And this is that rule. It's called the law of conservation of mass. Now, that sounds super formal, I know, but it's basically the universe's golden rule. All it means is that you can't create or destroy stuff. The total amount always stays the same. So that campfire wood, it didn't disappear. It just changed into other things, like ash, smoke, and some gases that we just can't see.
To make this crystal clear, let's forget chemistry for a second and just think about Legos. Imagine you build an awesome spaceship. Then you decide to take it all apart and use those exact same bricks to build a castle. You haven't lost any bricks, you haven't gained any bricks, you just have the exact same pile you started with, rearranged into something new.
Well, a chemical equation is just the chemistry version of that. Seriously, it's just a simple before and after picture. On the left side, you've got your starting models. We call those the reactants. And on the right side, you've got what you built. We call those the products.
And this analogy just lines up perfectly. So the individual Lego bricks, in chemistry, those are your atoms. The finished models you build, like the spaceship or the castle, those are the molecules. And the whole process of taking one apart and building something else, yep, that's your chemical reaction.
So here is the most important part. When you hear the phrase balancing the equation, don't let it freak you out. All it means, literally all it means, is counting your Legos. You're just making sure that the number of red bricks, blue bricks, and yellow bricks you started with is the exact same as the number you have at the end. It's not some crazy advanced math, it's just bookkeeping.
And luckily, there's a really simple 5-step game plan for this. 1. Write out the basic equation. 2. Do a quick tally of all the atoms on each side. 3, and this is the most important rule of all, you can only adjust the big numbers in front of the molecules, never ever touch the little numbers inside them. 4 is a great pro tip. Always save hydrogen and oxygen for last. And 5, just double-check your work to make sure it all adds up.
All right, enough talk, let's actually do one. We'll start with a classic, making water. Our starting point, our skeleton equation, is H2 plus O2 becomes H2O.
Okay, time to count our Legos. On the left, the before side, we've got 2 hydrogen atoms and 2 oxygen atoms. Got it. Now, over on the right, in our water molecule, we have 2 hydrogens, but wait a minute, only 1 oxygen. Uh-oh, one of our oxygen bricks is missing. This equation is definitely unbalanced.
So how do we fix this? We need more oxygen on the right side. Now remember the rule, we can't just change H2O to H2O2. That would be like changing the shape of the Lego brick itself. Can't do that. But what we can do is just say we're going to make 2 water molecules. We show that by putting a big 2 right out front.
Okay, let's retally. How's our oxygen looking? 2 on the left, and now 2 on the right. Perfect. But, whoops, in fixing the oxygen, we've created a new problem. We now have 4 hydrogen atoms on the right side, but still only 2 on the left. You know what? This is totally normal. It's just part of the puzzle.
And the solution here is really simple. To get 4 hydrogens on the left, we just need to start with 2 H2 molecules. So we just pop a 2 in front of the H2, and just like that, the puzzle is solved.
And there we have it. Let's do the final check. 4 hydrogens on the left, 4 on the right. Check. 2 oxygens on the left, 2 on the right. Check. Beautiful. Every single brick is accounted for. The law of conservation of mass is happy. Feeling good? Awesome. Let's level up and try a slightly trickier one. This is the equation for burning methane, which is pretty much what natural gas is. Our starting point is CH4 plus O2 gives us CO2 and H2O.
All right, let's do our inventory. On the left, 1 carbon, 4 hydrogens, 2 oxygens. Now the right, 1 carbon, 2 hydrogens, and be careful with the oxygen here. There are 2 in the CO2 and 1 in the H2O, so that's a total of 3. Okay, so our carbon is fine, but hydrogen and oxygen are all out of whack.
Remember our pro tip? We'll tackle hydrogen first. We need 4 hydrogens on the right, but we only have 2 right now. The easy fix is to just make 2 water molecules, so we put a big 2 in front of the H2O.
Okay, time for a recount. Carbon is still 1 to 1, great. Hydrogen is now 4 to 4, excellent. We're almost there. Now we just have to fix oxygen. We have 2 on the left, but on the right we now have a total of 4, 2 from the CO2 and 2 from our 2 new water molecules.
This last step is nice and clean. To get 4 oxygen atoms on the left, we just need to start with 2 O2 molecules. So we put a 2 right in front of the O2, and we are done.
And look at that final proof. 1 carbon, 4 hydrogens, and 4 oxygens on both sides. Every single atom we started with is still there in the end. They're just partners with different atoms now. The law holds true again. It's perfect.
So why does all this matter for you? Well, here's the deal. If you're studying for an exam like the GED, this is a really practical skill. But here's the secret. A lot of questions aren't about making you balance some impossible equation from scratch. They're usually testing just one thing. Can you look at an equation and just confirm that the number of bricks is the same on both sides? It's really a test of your accounting skills, not super advanced chemistry.
So, the next time you see a campfire, you'll know exactly what's going on. That matter isn't vanishing, it's just rearranging itself. Just remember the Legos. Count the bricks on the left, count them on the right, and make sure they match. That is the heart of it all. You can absolutely do this. You've got this. Good luck.